The economy described by the following: y is equal to c plus I plus g, where y is the income, c is the consumption expenditure, I is the investment expenditure, and g is the government spending. With the value of total income is equal to 5,000, government expenditure is 1,000, and t denotes the tax revenue, which is 1,000. Our consumption function is c is equal to 250 plus 0.75 y minus t. 250 denotes the autonomous consumption when the level of income is 0. 0.75 denotes the marginal propensity to consume, and y minus t denotes the disposable income. Where the symbols have the usual meanings, we need to find out the private savings in this economy. Okay, so private savings, if I write it here, private savings, that is denoted by P in an economy, is given by, that is equal to our total income minus the consumption expenditure minus the tax revenue. Okay, that means our P will be equal to, what is our total income, that is being given us as 5,000 minus consumption expenditure is, if I write it like this, so we have 250 plus 0.75, then y, again it is 5,000 minus tax revenue is 1,000. To this we subtract the taxes that are being given us as 1,000. Okay, so private savings will be equal to 5,000 minus, we have 250, or let us first solve this, plus 5,000 minus 1,000 is 4,000. Now 0.75 was 75 upon 100 into 4,000, so this gets cancelled, so we get 0, 4 sevens are 20, sorry, 4 5s are 20, 4 5s are 20, 4 sevens are 28, 29, 30, so we get here 3,000. So this term becomes 3,000. To this we subtract 1,000. That gives us private savings will be equal to 5,000. Then we have 3,000 plus 250, so it becomes minus 3,250. To this we subtract 1,000. So private savings will be equal to 5,000 minus, so let's add these two, so it becomes 4,250. So private savings will be equal to 0 goes 0, 10 5 5 9 2 7, 0 goes 0. So private savings in this economy will be equal to 750. The question is how to find out the value of the learner's index. The question goes like this: learner's index, a measure of market power, is defined as price minus marginal cost upon price. If the profit maximizing firm faces the demand curve as P square Q is equal to 7, where P and Q denote price and output, we need to find out the value of L. Okay, so we are being given the learner's index. Okay, by learner's index, what we mean, it is a measure of market power, the ability of a firm to charge price above the marginal cost. We call that what we call the market power, and the relationship is, that is learner's index is equal to price minus marginal cost upon price, which is equal to the absolute value of elasticity of demand. This is the relationship. We need to find out the value of L. So to find out the value of L, let us first find out the value of elasticity of demand. So we are being given the demand function as P square Q is equal to 7. Let us solve this for Q. So Q will be equal to 7 upon P square. We can write it like this: 7 times P raised power minus 2. Now elasticity of demand, as we know, it is simply the change in the output due to the change in the price times price divided by output. So dq upon dp, let us first find out this, means the derivative of this function with respect to price. Using power function rule, exponent becomes coefficient, so 2 into 7 is minus 14 here. Okay, so we have then p, and exponent is subtracted by 1, so we get minus 14 p raised power minus 3. This is our what we call this derivative. Then elasticity of demand will be equal to elasticity of dq upon dp, which is equal to minus 14. Let us write it like this, p cube here. If I transpose this, it becomes positive, the exponent. Okay, times p divided by q. Q is this function, that is 7 upon p square. Let's further solve this. So we have minus 14 divided by p cube into, so here we have p transpose, it gets multiplied here, so it becomes p square divided by 7. So we will get elasticity is equal to 7 ones are 7 twos are 14, so we get minus 2 divided by p cube into p square is p cube. This gets cancelled, so elasticity of demand is minus 2, absolute value of elasticity of demand is 2. Okay, having said that, so we have this relationship, price minus marginal cost upon price is equal to this stuff. So can I write price minus marginal cost upon price is equal to 1 divided by elasticity of demand is 2. Okay, so 1 upon 2 is equal to 0.5. If L is equal to this stuff and this stuff is equal to this, simple thing, so it means this is equal to, L is equal to 1 upon elasticity of demand. So elasticity of demand is 0.5, that means the learner's index will be the reciprocal of the elasticity of demand. Sorry, elasticity of demand was 2, so learner's index will be 0.5. The question is to find out the absolute elasticity of demand from the given demand function. The question is, demand curve for a commodity in your consumption basket is given by p square q raised power 5 is equal to 392.67, where p denotes the price, q is the quantity. The absolute value of your own price elasticity of demand for this commodity is we are supposed to find out. So we are being given the demand function as p square q raised power 5 is equal to 392.67. We need to find out the elasticity of demand. So we know that elasticity of demand in absolute terms will be equal to the change in the quantity demanded due to the change in the price times price upon quantity demanded at that very price. So first we need to find out this derivative dq upon dp. For that we need to solve this function for q. So can I write q raised power 5 is equal to 392.67 divided by p square. Okay, then since I only need q, so can I write q is equal to, transpose this, it becomes 1 upon 5 as exponent, so we will get 392.67 divided by p square whole raised power 1 upon 5, or q will be equal to 392.67 raised power 1 upon 5 divided by p, so we have 2 into 1 upon 5, which becomes 2 upon 5. Now we can find dq upon dp. So dq upon dp will be equal to derivative of this function with respect to p. Or if I further solve it here, so can I write it like this, 392.67 raised power 1 upon 5 times p raised power minus 2 upon 5. Okay, exponent sign changes when I transpose it here. Now the derivative of this function with respect to p, exponent of p becomes coefficient, so we have minus 2 upon 5 times 392.67 raised power 1 upon 5 times p raised power, exponent is subtracted by 1, so we have minus 2 minus 5, which is minus 7, sorry, minus 2 and minus 5 is minus 7 upon 5. Okay, Now, elasticity of demand, as we know, it is equal to dq upon dp. So elasticity of demand will be equal to dq upon dp, which is this stuff, which is minus 2 upon 5 times 392.67 raised power 1 upon 5 times p raised power minus 7 upon 5. To this we multiply by p divided by q. Q is what is q? Q is this very function. Okay, so can I write it like this? So q is 392.67 raised power 1 upon 5 divided by p raised power 2 upon 5. Solving further, first this 392, this gets cancelled, so we get minus 2 upon 5. Then we have p raised power minus 7 upon 5 into p, so it gets multiplied, it becomes into p raised power 2 upon 5. So we get minus 2 upon 5. Bases are same, we can add the exponent. So we have minus 7 upon 5 plus 1 plus 2 upon 5. Okay, so can I write it here? Multiplying numerator and denominator by 5, so we have minus 7 upon 5. In place of 1, can I write 5 upon 5 plus 2 upon 5. So we have the same denominator, so let's write 5. Here we have minus 7 plus 5 plus 2, so it becomes minus 7 plus 7 divided by 5, so which is equal to 0 upon 5, which is equal to 0. So this stuff will be equal to p raised power 0. So anything raised power 0 is 1. So we get elasticity of demand is equal to minus 2 upon 5. But we are supposed to find out the absolute value of the elasticity of demand, which is minus 2 upon 5, which is equal to 2 upon 5. And 2 upon 5 is, what is 2 upon 5? So 2 upon 5 is, we have 2 here, 5.0, 5 4s are 20. So we have 0.4 as the absolute value of price elasticity of demand for the given commodity. The question is to find out the present value of perpetual cash flow. The question is, the present value of perpetual cash flow of $200 discounted at the rate of 10% each year is, we are supposed to find out. Now the present value of a perpetual cash flow is calculated by dividing the annual cash flow by the discount rate. Okay, so present value of cash flow will be equal to, so we have 250, which is the annual cash flow, 250. To this we divide by the discount rate, which is being given us as 10%. So which is equal to 250 divided by 10 divided by 100, which is equal to 250 divided by 1 into 100 upon 10. This gets cancelled. Our present value of perpetual cash flow will be 250 into 10, which is equal to 2500. The question is to find out the unemployment rate. The question is, the composition of adult population in an economy is as follows. Employed person is 140 million. Unemployed persons are 10 million. Not in labor force is 50 million. We are supposed to find out the rate of unemployment. Okay. So unemployment rate, if I write it here, unemployment rate is equal to, that is equal to the number of unemployed person, that is unemployed, divided by the sum of the employed and unemployed, that is employed plus unemployed, into 100%. Okay, so unemployment rate in this case is, unemployed is 10 million, divided by employed plus unemployed is 140 plus 10, which becomes 10 divided by 150. So this will multiply by 100%. So this will come out to be 6.67, I guess. So this should be the correct answer. That is 6.6%. 6.67% will be the unemployment rate. Question is how to find out the monthly average price. The question is price of milk of certain brand was 28 rupees per liter and 36 per liter in the months of September and October of 2015 respectively. Assume equal amounts of money is spent on that brand of milk by a particular family in each of these months. The average monthly price of milk paid by this family during these months is we are supposed to find out. Okay. So price of milk for October. So let me write it here, for September is 28 rupees. For October it is 36. Okay. We are also being told that this family spends equal amount of money for the consumption of milk for September and October. Let us take any arbitrary number. Let us suppose this family spends amount spent each month, or amount spent each month is 100. Okay, that means 100 for October and 100 for September. Okay. Therefore, number of liters bought for September. Okay, for September, let us write me the superscript S is September will be equal to the amount spent, which is 100, divided by the price of milk, which is 28. This will be the number of liters bought in the month of September. Similarly, number of liters of milk bought in the month of October will be equal to the total amount spent, because this family spends equal amount in each month. So it is 100 divided by the price of milk, which is 36. Now, average price of milk for September and October. I am doing this superscript to show September and October. This is not any standard notation of showing this stuff. For the sake of simplicity, I am doing it here. Okay, will be equal to, what will be the average price of the milk then for the months of September and October? It will be equal to the total amount spent in these 2 months divided by the total amount of milk bought. So that will be equal to total amount spent okay, that is September plus October divided by the total amount of milk bought for these months September and October. That will give us the average price. So average price will be equal to, so total amount spent is, for the month of September it is 100, for the month of October it is 100. Total amount of milk bought is 100 divided by 28, and we have 100 divided by 36. Okay, solve it. So average price will be equal to, so 100 plus 100 is 200 divided by, this gives us 3600 plus 2800. So we have 3600 plus 2800 divided by 28 into 36. Okay, when you solve this, it is pretty simple. Average price will come out to be 31.5 rupees. Okay. The question is to find out the income elasticity for the given utility function. The question is, consider a consumer with the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, where x and y are the quantities of two commodities consumed. Which of the following is true? Options are: income elasticity of demand for both the goods is equal to 1. Income elasticity of demand for good x is 0. Income elasticity of demand for good y is 0. And last option is income elasticity for good x is 0.5 and for good y it is 1. We need to find out the correct option. Okay, so we are being given the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, can be written as x raised power 1 upon 2. Okay, so this is actually our quasi-linear utility function. Okay, so our endeavor is to find out the demand function for x and y. Then we can find out the income elasticities. Okay, so our endeavor is to maximize utility, which is equal to y plus x raised power 1 upon 2, subject to the budget constraint, that's price of x times units of x plus price of y times units of good y should be equal to the income of the consumer. So for optimality, we know that we equate marginal rate of substitution between good x and y, and it should be equal to the ratio of the prices. Okay, so MRS, as you know, it is MUX upon MUY. It should be equal to PX upon PY. MUX means the change in the utility due to the change in the consumption of good x. MUY means the change in the utility due to the change in the consumption of good y should be equal to price of x upon price of y. Now derivative of this function with respect to x gives us, that is the derivative of y will be 0 because we are taking partial with respect to x, so it is 0. So we get here 1 upon 2 x raised power minus 1 upon 2, the derivative of x raised power 1 upon 2 here. Okay, divided by derivative of y is 1, should be equal to px upon py. Okay, so we got here 1 divided by twice x raised power 1 upon 2 if I transpose it to the denominator, which is equal to px upon py. Okay, solve for x. So can we write it like this: 2x raised power 1 upon 2 is equal to py upon px, or x raised power 1 upon 2 is equal to py upon px times 2, or let's write it here twice, or x will be equal to transpose under root, it becomes square, so we get 4 py square divided by px square. This is the demand function for good x here. Now demand function for good y is, plug this value somewhere, or plug this value into the budget constraint, that is, so p will be equal to, so price of x times the value of x is 4 py square divided by px square. Okay, I hope I am within the limits. So okay, this stuff here, so px times x is this, plus py times y is equal to m. Solve for y, so y will be equal to, so here 1x gets cancelled, so we get 4 py square divided by px plus py times y is equal to m, or py times y is equal to m minus 4 py square divided by px, or if I write it here, y will be equal to, transpose this, it gets divided, so m divided by py times 4 py square divided by px. Okay, so this is the demand function for good y. This denotes the demand function for good x. This is actually our quasi-linear utility function. What is meant by quasi-linear utility function? I have explained it in my earlier videos. You can check it out. I don't have time and space here to show that very thing. So what is the elasticity of demand formula for good X? So elasticity of demand is the change in the consumption of good X due to the change in the income times income upon X. Okay. Now if this is our demand function, its derivative with respect to income is 0 because income is not here, M is not here. That means this will be equal to 0. That is, this derivative will be equal to 0. So elasticity, income elasticity of demand for good X will be equal to 0 times M upon X. So elasticity of demand for good X will be equal to 0. So let us see if we have that very option, then we can discard the other option. So elasticity of demand for good X is 0. So this option must be correct. Okay. I hope I am making myself clear. Question is to find out the value of the determinant A raised power 5 in the question. The question is matrix A is 4, 12, minus 1, minus 3. The value of the determinant A raised power 5 is we are supposed to find out. So we have the matrix A is equal to, which is equal to 4, 12, minus 1, minus 3. We are supposed to find out A raised power 5, its determinant. Okay. This is we are supposed to find out. Now the property of determinant, one of the properties that if we have that is, if we have A raised power n, the determinant of A raised power n is in fact equal to the determinant of A whole raised power n. By this what we mean? So we have A raised power 5. It can be written like this, whole raised power 5. So let's first find out the determinant of A. So determinant of A, let us find out. We multiply these two elements first. Okay, principal diagonal element, that is 4 into minus 3. From this we subtract the product of the non-principal diagonal elements, that is 12 times minus 1. So it becomes minus 4 into 3 is minus 12, minus 12. Okay, then we have minus 12 into minus 1 is minus 12, minus into minus is plus 12. So we get here 0. That is, we got determinant of A is equal to 0, and we are supposed to find out the determinant of A raised power 5, which is equal to 0 raised power 5, which is equal to 0 in this case. The question is, suppose utility function of a consumer is, utility is a function of two goods X and Y, which is equal to X times Y, where X and Y are quantities of commodities consumed. If price of X is $1 and price of Y is $2 and income of the consumer is $100, we need to find out the utility maximizing quantity consumption of good X. Okay, so what we are being given here, we are being given the utility function, that is U is a function of, utility is a function of two goods X and Y, which is related with the function X times Y. Okay, price of good X is $1, price of good Y is $2, that is being given also. Income of the consumer is $100. Okay, we need to find out the utility maximizing quantity. Okay, so that means our endeavor is to maximize the utility of the consumer, that is equal to X times Y, subject to the budget constraint that he is facing. What is the budget constraint? That is price of X times units of good X plus price of Y times units of good Y should be equal to the income of the consumer. Price of X is 1, so we can write X here, plus price of good Y is 2, so we can write 2 times Y should be equal to the income of the consumer, which is given here 100. Okay, so consumer's endeavor is to maximize his utility subject to the budget constraint. Graphically it means, if I draw a simple graph here, we have units of good X on the horizontal axis, units of good Y on the vertical axis. Okay, with the given budget constraint, let's draw here. This is the budget constraint. Consumer wants to achieve highest possible satisfaction. Okay, let us say this is IC1, this is IC2. So at optimality or utility maximizing condition, what happens? Consumer will reach to that very indifference curve while it is tangent to the budget line. Okay, so this is the point where they are tangent to each other. At tangency, we know that means first order condition for optimization in this case requires that the marginal rate of substitution between a good x and y should be equal to the ratio of the prices, price of x upon price of y. Okay, that means what's MRS? MRS is slope of IC, and PX upon PY is slope of budget line. Okay, so MRS is simply the marginal utility of x upon marginal utility of good y. It should be equal to the ratio of the prices. MUX is simply the change in the utility due to the change in the consumption of good x, and similarly MUY means the change in the utility due to the consumption of good y should be equal to the ratio of the prices. Okay, du upon dx means the partial derivative of utility function with respect to x. So derivative of x is 1, we are left with y, divided by du upon dy means derivative of the utility function with respect to y, so we are left with x. Price of x is 1 and price of good y is 2. Solving for this, so we get x is equal to 2y. Now what we do, we plug the value of x is equal to 2y into the budget constraint. Okay, so we have here, that is in place of x we have 2y, plus then we have 2y should be equal to the income, or 4y is equal to 100. Dividing both sides by 4, we get y is equal to 100 upon 4, which comes out to be 25. Okay, but we are supposed to find out the value of x, utility maximizing quantity of x. So plug y is equal to 25 in this equation. That means x will be equal to 2 times what we have done here, we got the value of x is equal to okay, that is correct. X is equal to 2y means x is equal to 2 times the optimal value of y. If I write it here, it is 25, so x will be equal to 2 into 25, which is equal to 50. So 50 will be the optimal consumption of good x. Next question is, a monopolist produces a product and sells to two types of buyers, A and B. The inverse demand function for A and B are P is equal to 50 minus 5Q. P is the price, Q is the quantity of output, and P is equal to 100 minus 10Q. This is for the second buyer, which is B respectively. The monopolist's cost function is C is equal to 90 plus 20Q. The profit maximizing output of the monopolist for buyer B is, we need to find out. Okay, so we are being given the monopolist. We have two buyers. A, for A the demand function is, that is P is equal to 50 minus 5Q. For B the demand function is P is equal to 100 minus 10Q. Also cost function for the monopolist is 90 plus 20Q. Okay, we need to find out, if the monopolist wants to maximize profit, how much amount of output the monopolist should produce for buyer B. Okay, so we know that for profit maximization in case of what we call monopoly, we equate the marginal revenue for buyer B should be equal to the marginal cost. Okay, first we need to find out the total revenue for buyer B. So total revenue will be P into Q. So P is being given for buyer, we are being given P is 100 minus 10Q, times to this we multiply by Q. Okay, so I am within the limits. So total revenue for buyer B will be equal to 100 Q minus 10 Q square. Marginal revenue for buyer B will be equal to the derivative of total revenue for buyer B upon the derivative of the output. So differentiating this with respect to, so we have to use the simple derivative, not partial here. So we differentiate it with respect to Q. Derivative of Q is 1, so we are left with 100 minus derivative of Q square is 2Q, so 2 into 10 is 20Q. This is the marginal revenue for buyer B. Similarly, we need to find out the marginal cost. Marginal cost is the change in the total cost due to the change in the output. So we differentiate this cost function with respect to Q. So derivative of a constant is 0, derivative of Q is 1, so we are left with 20. Now equating marginal revenue with the marginal cost. Marginal revenue is 100 minus 20Q, and we equated the marginal cost, which we got is 20. Solving further, transpose this here and this there, so we get 100 minus 20 is equal to 20Q, which implies 80 is equal to 20Q, rather 20Q. So we got 20Q is equal to 80, dividing 20, dividing both sides by 20. Q will be equal to 2 1s are 2 4s are, so Q will be equal to Q will be equal to 4. Okay. Next question is, suppose the GDP growth rate is 8% and the rate of savings in the economy is 40%. The incremental capital output ratio is, we are supposed to find out. Okay. So we are being told that growth rate of the GDP for the economy is 8% and savings rate is equal to 40%. Okay, we need to find out the incremental capital output ratio. Now what is incremental capital output ratio? It is simply the ratio of the investment and growth. That is, we know from Harrod-Domar model. One of the assumption is that savings is equal to investment. That means the incremental capital output ratio is simply the ratio of savings and growth. The formula is being given, that is growth rate is equal to savings rate upon incremental capital output ratio. Growth rate is 8%. Savings rate is being given as 40%. And we are being supposed to find the incremental capital output ratio. Multiplying this with this, so we get 8% times ICOR is equal to 40%, which gives us ICOR will be equal to, transpose this here, it gets divided, so we have 40% divided by 8%. Okay, so so it should be like this. Okay, now I am within the limits, so ICOR will be equal to 8 1s are 8 5s are, that means incremental capital output ratio for this economy is 5. Okay, it simply means ICOR means we need 5 units of money or $5 or 5 units of currency to make 1 more unit of output for the economy. Next question is, suppose an economy produces 100 kg of rice in a year and sells that for $100 per kg. If the quantity of money in the economy is $500, then the velocity of money is, we need to find out. So by velocity of money, what we mean? By velocity of money, we mean, or rather we denote it by V. velocity of money measures the number of times one unit of currency is used to purchase goods and services within the given period in an economy. That is, velocity of money measures the number of times one unit of currency is used to purchase goods and services within a given period. Okay, so let me rub this out. To find out the velocity of money, here we are being given, so we use the quantity theory of money to cut it short here. So according to the quantity theory of money, the relation is money circulation or money supply times velocity of money is equal to price level times the GDP. Here GDP is output here, that is 100 kg. So money supply is being given as the quantity of money, that is the money supply is here 500 times V should be equal to what is the price is rather 100 times the output produced is 100, which implies 500 V is equal to auxiliary transfer 1 2 3 4, or V will be equal to dividing both sides by 500, or we have divide by 500, you go yes with 10 into 10 is 5 into 20. So okay, so velocity of money is equal to 20 in this case. Okay, I hope it's clear to you. Next question is related to Nash equilibrium. The question is the sum of payoffs to the players in the Nash equilibrium of the following simultaneous game is. We are being given the payoff matrix for two players. We have two players, player X and player Y, and their strategies are cooperate or not to cooperate. And similarly for player Y, we have cooperate or not to cooperate. Payoffs are being given in the cells. The first element in each cell denotes the payoff for player X, and the second element in each cell denotes the payoff for player Y. Or let me write it here with another color. So we have here 40, here we have 30, here we have 20. Okay, so the black number denotes the payoff for player X when she or he chooses a specific strategy, and similarly the red ones are the payoffs for player Y when she or he chooses a specific strategy. We need to find out the Nash equilibrium in this case, and we need to add the payoffs of the players. So let's first find out the Nash equilibrium. By Nash equilibrium, what we mean, Nash equilibrium is a situation in which a player chooses his best strategy given the other person or player has also chosen his or her best strategy. And why does this happen in this question? So how do we solve? Let me explain that very stuff here. So let us suppose player X cooperates. Okay, so when player X cooperates, player Y has two choices, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate gives him 30 as payoff. Obviously 50 is greater than 30, so let us underline this. Likewise, let us see when player X chooses to not to cooperate. Again, player Y has two options, either to cooperate or not to cooperate. Cooperate gives him 40 is payoff, not to cooperate gives him 20. Obviously 40 is greater than 20. Since we assume that the players are rational, they will choose higher payoff. Now let us see from the perspective of player X when player Y has chosen to cooperate. When player Y chooses to cooperate, again player X has two options, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate as 30. Obviously 50 is greater than 30. He will choose to cooperate. Symmetrically, when player Y chooses not to cooperate, again player X has two options, either to cooperate or not to cooperate. So cooperate gives him 40, which is greater than 20. So she or he will choose 40. Now, where does the Nash equilibrium exist in this question? When both the numbers in a particular cell are underlined or encircled or whatever you call, that will give us the Nash equilibrium. Nash equilibrium cannot be Pareto optimal at times, okay? But it is the best strategy for both the players to cooperate in this simultaneous game. Now we need to find out the sum of the payoffs. So sum of the payoffs will be at Nash equilibrium, which is 50 plus 50, which is equal to 100 in this case. Next question is the derivative of y is equal to x raised power e raised power x at x is, we need to find out, okay, the derivative. So we have y is equal to x raised power e raised power x, okay. Let us first take the log on both sides, okay. That means log of y is equal to, now what is log of x raised power e raised power x? So e raised power x will become first coefficient times log of x, okay. Or let me write it with another color. We have log of x here, okay. This is our okay. So now let us differentiate it. So however, the derivative of log of y is, we know it is 1 upon y dy upon dx. Now on the right hand side we apply the product rule, that is we write the first function e raised power x and take the derivative of second function, which is log of x, plus then we write the second function log of x and take the derivative of the first function, which is e raised power x, okay. So let me use the proper color here. We have e raised power x, here we have also e raised power x, okay. So we have 1 upon y dy upon dx, okay. Let me put it like this, is equal to, now we have e raised power x, derivative of log of x, we know it is 1 upon x, color combination की तेल लेने, plus log of x times the derivative of e raised power x is e raised power x, okay, times e raised power x, we know that very thing. Then dy upon dx will be equal to, transpose this y, it gets multiplied, so we have y times e raised power x divided by x plus log of x times e raised power x, or dy upon dx is equal to, y is this function, the given function x e raised power x, then we have e raised power x upon x plus log of x times e raised power x, okay. But we need to find dy, the derivative dy upon dx when x is equal to 1. Plug the value x is equal to 1 here. So we have 1 raised power e raised power 1, then we have times e raised power 1 divided by 1 plus log of 1 times e raised power 1. So we have 1 raised power anything is 1. Okay, then we have e raised power 1 plus log of 1 is 0 times e raised power 1. So we get here so 1 into something is something, so we have e raised e plus 0, which is equal to e, and the value of e is, I guess, 2.71. Okay, so the correct option should be 2.71 here. To find out the own price elasticity of demand of a logarithmic demand function. The question is, the demand function is given as log of q is equal to log of a plus 0.5 log of p, where q is the quantity, p is the unit price of good, and a is a positive real number. The own price elasticity of demand is, options are perfectly elastic, perfectly inelastic, elastic, or inelastic. Okay, so what we are being given here, we are being given the demand function is log of q is equal to log of a plus 0.5 log of p. Okay, what is the formula for elasticity? So if I write the absolute value of elasticity of demand, that is given by the change in the quantity demanded due to the change in the price times price upon quantity demanded at that very price. Okay, for perfectly elastic, the absolute value of elasticity of demand should be equal to infinity. For perfectly inelastic, the absolute value of elasticity of demand should be equal to 0. Okay, for elastic, the absolute value of price elasticity of demand should be greater than 1, and for inelastic, the absolute value should be less than 1. Okay, these are the conditions, and in this case our demand function will look like this. So if we have quantity here, price here, this denotes the demand function in case of perfectly, or rather this is the graph for, if this is demand function, this is for perfectly inelastic. So for perfectly elastic, our demand function will be like this. For elastic, it will look like, rather for elastic, so elastic will look like this. For inelastic, the graph will look like what can I say, like this. Okay, we need to find out the elasticity of demand, and we are being given the logarithmic demand function. So first what will we do, we take differential on both sides, that is the differential of log of q will be 1 upon q times dq plus log of a, where a is constant, since it is a constant term, its derivative will be equal to 0, plus 0.5, let's write it as 1 upon 2 rather, times the derivative of log of p is 1 upon p times dp. Okay, let's transpose this dp here, so we get dq upon dp is equal to, and let's transpose this q here, so we will get 1 upon 2. If I transpose, it gets multiplied, so here we have q divided by 2p. This is our dq upon dp. Now elasticity of demand, as we know, in absolute terms is equal to dq upon dp, which is equal to q upon twice p times p divided by q. Okay, here p and p gets cancelled, q and q gets cancelled, so absolute value of price elasticity of demand is 1 upon 2, which is equal to 0.5. so elasticity of demand is less than 1, that means the own price elasticity of demand in this case, so E is less than 1, so it will be inelastic in this case. The question is how to find out the partial derivative of the given function. The question is,
Let f of x comma y comma z is equal to x square y cube z. Okay, we have this multivariate function. Then we need to find out x times the partial derivative of this function with respect to x plus y times the partial derivative of this function with respect to y plus z. The times the partial derivative of this function with respect to z should be equal to, options are being given. We need to find out the correct option in this case. Okay, so what we are being given, we have the function f of x comma y comma z is equal to x cube, we have x square y cube z. Okay, and we are supposed to find out x times del f upon del x of x comma y comma z plus y times del f upon del y times x comma y comma z plus z times del f upon del z of x comma z should be equal to. Okay, so let's write first x. The derivative of this function with respect to x will be, so the exponent of x becomes coefficient and exponent is subtracted by 1, so 2 becomes coefficient, so we have x times twice x y cube and z will remain same because we are taking the partials, plus y times the derivative of this function with respect to y. In this case x square will remain same, derivative of y cube will be equal to 3y cube, so we have 3y square, rather exponent is subtracted by 1 and z will remain same, plus then we have z times the derivative of this function with respect to z. Derivative of z is 1, so we are left with x square y cube. Okay, so here we got twice x square, so twice x square y cube z, plus here we have 3, first 3, then we have x square, y into y square is y cube times z, plus here we have, let's write first x cube times, rather we have x square times y cube times z. Okay, so if I take x square y cube z common, so x square y cube z if I take common, so here we are left with 2, here we are left with 3, and here we are left with 1, so we will get 2 plus 3 plus 1 is 6, so we get 6 times x square y cube z, which is equal to 6 times, what is x square y cube z? It is a given function, that is f of x comma y comma z. The question is to find out the maximum profit for the monopolist. The question is, the inverse demand function for a monopolist is given by P is equal to 100 minus KQ, where P is the unit price of good, Q is the quantity, and K is a constant. The cost function facing this monopolist is given as CQ, that is cost is equal to 50 plus twice Q times 1 plus Q. If the profit maximizing output is given as 7, we need to find out the maximum profit. Okay, so we are being given the demand function as P is equal to 100 minus KQ. This is demand function, and we are also being given cost function as 50 plus twice Q 1 plus Q, and we are being told that profit maximizing output is, that is Q star is equal to 7, and we are supposed to find out the maximum profit. Okay, so for a monopolist, what is the profit maximization condition? So for monopolist, we know that for monopolist, profit maximization requires we equate the marginal revenue with marginal cost. Okay, this is one thing, or we can first find out. Okay, let's solve it by another method, that is what will be the total profit for the monopolist? That will be equal to total revenue minus the total cost. Okay, so profit will be equal to total revenue is price into quantity minus total cost is being given us. Okay, so price is 100 minus KQ, 100 minus KQ, to this we multiply by Q, minus total cost is being given us as 50, plus here we have twice Q, then we have plus 2 into q square is twice q square. Okay, so we have 100 q minus k q square. Then we have minus 50 minus twice q minus twice q square. Okay, so let us solve it further. So we have 100 q minus 2q. Okay, so 100q minus 2q is 98q. Then we have minus k q square. Then we have minus twice q square minus 50. This is our profit function. Okay, for profit maximization, our marginal profit should be equal to 0. That is, the derivative of profit function with respect to output should be equal to 0. That means our marginal profit should be equal to 0. We need to differentiate this function with respect to q. Derivative of q is 1, so we are left with 98 minus derivative of q square is twice. Then we have k, then we have q minus 2 2s are 4 again, so we have 4q, and derivative of a constant is 0, and we equate it to 0. Okay, we are being told that profit maximizing output is 7. So let us plug q is equal to q star, which is equal to 7 in this equation. So we have 98 minus twice k into 7 minus 4 into 7 is equal to 0. So first we need to find out the value of k here. Okay, so 4 7s are 28, or we have 98 minus 14 k minus 28 is equal to 0. Okay, so we have 98 minus 28, or let us transpose it here. So we get 14, k is equal to, so 8 minus 8 is 0, 9 minus 2 is 7, which gives us k will be equal to, k is equal to 70 divided by 14, which comes out to be, so 7 2s are 7 10s are 2 1s are 2 5s are. The value of k came out to be 5, but we are supposed to find out the maximum profit. Okay, since this is our profit function, so maximum profit will be equal to, so we have 98 times profit maximizing output is given us as 7 minus k, the value of k which we got as 5, times k is 7 square minus 2 into 7 square minus 50. Okay, let me see if I am within the limits. That means profit will be equal to, so 7 8s are, here I can get confused, I have to solve it manually. 7 7s are 49, 7 8s are 56. Okay, 9 7s are 63, and 5 which is 111. Sorry, 7 8s are 56, 7 9s are 63, 64 65 66 67 68. 9 7s are 63, so we got here 68. Okay, 68 minus, we have 5 times 49 minus 2 into 49 minus 50. Okay, so profit will be equal to 686 minus 5 9s are 45, 5 4s are 20, and 4 is 24, minus, here it becomes 49 times it becomes 98 minus 50. Okay, then we need to add these things, so profit will be equal to 686 minus, so we have 0 plus 8 plus 5, oh, now the kaba through, so here we got 3, then we have now to pass me sada panda shara sada arda tagi kunu, then we have 2 tagi 3, so we have 6 8 6 now logos khabar kya jaise galat gumo 3 9 3 shan 3 8 9 9 to 9 5 9 after sorry 293. Okay, I guess if I have done the calculation right, it should be 293 should be the maximum profit. Okay, I am not sure about the calculation. The question is to find out the Carnot solution for the given oligopoly model. The question is, consider a three firms oligopoly market with a linear demand function given by P is equal to 25 minus Q, where P is the unit price and Q is the quantity supplied. The total quantity, which is Q, is equal to Q1 plus Q2 plus Q3, where Qi is the output from the ith firm with I equal to 1, 2, 3. The total cost of a firm I is given by, that is total cost PC subscript I is equal to AI plus 5QI, where AI's are positive real numbers. Assuming a Carnot solution exists, the value of Q, that is total quantity supplied in this market, is equal to, options are 9, 15, 12 or 21. Okay, so this is a Carnot model and we are being given the demand function, market demand function, that is P is equal to 25 minus Q. Okay, this is the market demand function. How do we solve the Carnot model? In this case, we know that in the Carnot model, firms compete in terms of quantities. Okay, equilibrium occurs where what we call the reaction curves of the firms intersect with each other. Okay, and how to find out the reaction firms? Let us first find out. Since we have three firms oligopoly model and we have symmetric cost here, okay, we have the symmetric cost here. Let us take the first firm, that is firm 1, and find out the reaction firm for firm 1. So this is the market demand function. Can I rewrite it like this? P is equal to 25 minus Q is equal to Q1 plus Q2 plus Q3. Here it is shown in a small caps, so I will write it in larger caps, that is in capital letters, because I get confused with Q's as 9. So can I write it like this? Q1 plus Q2 plus Q3. Okay, so total demand function will be 25 minus Q1 minus Q2 minus Q3. Okay, let us first find out the reaction function for firm 1. Reaction function for firm 1. For firm 1, what is the equilibrium condition? That is the marginal revenue of firm 1 should be equal to the marginal cost of firm 1. To find out the marginal revenue of firm 1, first we need to find out the total revenue of firm 1, which will be equal to price times the quantity of firm 1, which will be equal to, so P is this very function, so we have 25 minus Q1 minus Q2 minus Q3. To this we multiply by Q1. So total revenue of firm 1 will be equal to 25 Q1 minus Q1 square minus Q1 Q2 minus Q1 Q3. This is the total revenue of firm 1. What is the marginal revenue of firm 1? So marginal revenue of firm 1 will be the change in the total revenue of firm 1 due to the change in the quantity of firm 1. That is the partial derivative of this function with respect to Q1. Derivative of Q1 is 1, so we are left with 25 minus derivative of Q1 square is twice Q1 minus derivative of Q1 is 1, so we are left with Q2, and here again Q1 is 1, so we are left with Q3. Okay, this is the marginal revenue function for firm 1. What about marginal cost? So total cost for firm 1 will be equal to, so TCI, in place of I write 1, which will be equal to A1 plus 5 times, so QI is Q1. So I am writing small q 1 is Q1 for the sake of simplicity. Okay, problem gasan huliakhnas. Having said that, what will be the marginal revenue, rather marginal cost of firm 1? That will be the change in the total cost of firm 1 due to the change in the output. Derivative of this function with respect to Q1. Derivative of a constant is 0, derivative of Q1 is 1, so we are left with 5. Now equating marginal revenue with marginal cost. So marginal revenue, this very function 25 minus twice Q1 minus Q2 minus Q3 is equal to 5. Okay, what will we do? Let us transpose this to this side and this side. So these becomes positive, so we have twice Q1 plus Q2 plus Q3 is equal to, so 25 minus 5 is 20. This is the reaction function for firm 1. Rather, if I solve it for Q1, then I will get the reaction function. Okay, reaction function simply shows how much quantity firm 1 will produce given others have produced their optimal quantities, that is firm 2 and firm 3. This is one of the equation for firm 1. Rather, this is the equation for firm 1 as reaction function. Since we have the symmetric cost, so output produced by each of the firm will be same. So symmetrically, what will be the reaction function for firm 2? That will be equal to, if you solve again, that is marginal revenue of firm 2 should be equal to marginal cost of firm 2. We will get Q1 plus twice Q2 plus Q3 will be equal to 20. Similarly, if you solve for MR3 is equal to marginal cost of firm 3, it will come out to be Q1 plus Q2 plus twice Q3 is equal to 20. Okay, so we have three equations with three variables and we need to solve this. Okay, we apply, and let me rub this out with heavy heart. So we need to write them into the matrix form. Okay, so in matrix form, that is A x is equal to B, where A is the coefficient matrix. Okay, so A will be equal to the coefficients of Q1, Q2 and Q3. Coefficient of Q1 is 2 in the first equation. In the second equation it is 1, third it is also 1. Here we have 1, 2, 1, then we have 1, 1, 2. X is here what we are supposed to find out, the quantity of Q1, Q2 and Q3. And B is the vector of constant terms, that is 20, 20, 20, 20, 20, 20. Okay, this is the in the matrix form. We need to find out the value of Q1. Okay, first thing is, okay, I am within my awkat. First I need to find out the determinant of the coefficient matrix. How do I find the determinant? So we write the first term, okay, then mentally delete the row and the column in which it appears and multiply it with the resulting determinant. So we have 2 2s are 4, minus 1 1s are 1. Then we write minus and write the second term and mentally delete the row and the column in which it appears and take determinant of the remaining element. So remaining elements are 1 1 1 and 2. So 1 2s are 2, minus 1 1s are 1. Then we have plus. Then we write the third term, that is 1, and delete the row and the column in which it appears and take the determinant of the remaining element. So we have 1 1s are move on. Then subtract 1 into minus 2, which is minus 2. Solving this, so determinant of A will be equal to, so we have 2 times 3, then we have minus 1 times 1, then we have plus 1 times minus 1. So we will get 2 3s are 6, minus 1, which is equal to 4. So determinant of A is equal to 4. Now to find out the optimal quantity of Q1, what we do, we apply the Kramer's rule. Okay, so in the Kramer's rule, what we do, to find out the optimal value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms and form a new matrix, that's A1. So A1 will be equal to, so to find out the value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms. So in place of 2 1 1, we write 20 20 20. So we have 20 20 20. Then we have 1 2 1 and 1 2 1 and 1 1 2. Then we take its determinant. Okay, so A1. Let's take its determinant. So we have 20. Delete the row and the column in which it appears and take the determinant of the remaining element. So 2's are 4 minus half. Then we have minus 1. Delete the row and the column in which this appears. So we have 20 into 20, which is 40, minus, sorry, 20 into 2 minus 20 into 1 is 20. Then we have plus 1. Delete this row and this column, so we have 20 minus 40, 20 minus 40. Okay, so A1 will be equal to 20 into 3 minus 40 into 2 is 40 minus 2 is minus 2, rather it's plus 20. Then we have again minus 20. So we have 60 minus 20 minus 20, which is 60, minus 40, which is equal to 20. So determinant of A1 is equal to 20. Now what will be the optimal value of Q1? Okay, using Cramer's rule, what we do? So let me repeat it again. To find out the optimal value of Q1, we form a new matrix A1 in such a way that we replace the first column of the coefficient matrix with the vector of constant terms. Sorry. And take the determinant of that very matrix. Then the value of Q1 will be equal to the determinant of this new matrix format divided by the determinant of the coefficient matrix, which is 20 upon 5, rather 4, which comes 4 ones are 4 5s are 20. So Q1 will be equal to 5. Okay. What about Q2? If we want to find out the value of Q2, what we will do? We will replace the second column of the coefficient matrix with the vector of constant term. Let me see, I have the space, and let me explain it here. I will not compute it. So then we need to find out the second matrix by replacing. To find out the value of Q2 star, we replace the second element, the second column of the coefficient matrix with the vector of constant term. So we have 2 1 1. We replace this column with 20 20 20 20 20. Then we have 1 1 2 and take its determinant. Okay, A2. It will come out to be, it should come out to be 20. Symmetrically, to find out the value of Q3, okay, you don't need to do it here. I will explain why. So to find out the value of Q3, what will we do? We form a new matrix, that is K3, or rather A3, by replacing the third column of the coefficient matrix with the vector of constant term. So we have 2 1 1 1 2 1. Then we have 20 20 20. Its determinant will also come out to be 20. Okay, so you don't need to calculate them. Then Q2 will be equal to A2 divided by A, which is 20, divided by 4, which is equal to 5, and Q3 will be equal to the determinant of A3 upon A, which is equal to 20 upon 4, which is equal to 5. We don't need to do this step, but I was just trying to explain it you about the Cramer's rule here. Okay, since Q1 is equal to 5 and we have the symmetric costs for the firms, that means Q1 will be equal to Q2 will be equal to Q3. Okay, that means total output will be equal to in this market will be equal to, since Q is equal to Q1 plus Q2 plus Q3 and Q1 is equal to 5, that means Q2 and Q3 is also 5, so Q will be equal to 5 plus 5 plus 5, which is equal to 15. Okay, the question is to find out the equilibrium output from the given consumption and investment function. The question is, for a closed economy with no government expenditure and taxes, the aggregate consumption function is given by C is equal to 100 plus 0.75 YD, where C denotes the consumption, 100 is the autonomous consumption when the level of income is 0, 0.75 denotes the marginal propensity to save, and YD denotes the disposable income. If the total investment is 80, we need to find out the equilibrium level of output. Okay, so we have the consumption function C is equal to 100 plus 0.75 YD. Investment is being given, that is equal to 80 here. We are supposed to find out the equilibrium level of output. Okay, so we know that at equilibrium our Y should be equal to the consumption expenditure plus investment expenditure. That means Y will be equal to, income will be equal to, consumption expenditure is 100 plus 0.75 Y plus investment is being given as 80. So we get here Y is equal to 100 plus 80 is 180 plus 0.75 Y. Transpose this to LHS, it gets subtracted. So we have minus 0.75 y is equal to 180, which implies subtract 0.75 y from y, we get 0.25 y is equal to 180, which implies 0.25 is 1 upon 4 y is equal to 180, or y will be equal to, transpose this, it gets multiplied, so we get 4. So equilibrium level of income will be equal to 4 zeros are 0, 4 8s are 32, 4 1s are 4, 5 6 is 7, 720 will be the equilibrium level of income in this economy. This question is about Cobb-Douglas production function. The question is, a Cobb-Douglas type short-run production function is given by Q is equal to twice under root L times K, where Q, L, K are output, labor and capital respectively. K is fixed at K bar, the unit price of L is W and unit price of K is R. It's given that W is equal to 12. Which of the following statements is or correct? Okay, so it is multi-select the option. One, more than one option can be correct here. So we have the short-run Cobb-Douglas production function, that is our Q is equal to twice. So in place of L under root LK, can I write L raised power 1 upon 2, K raised power 1 upon 2. Okay, simple thing. We are being told that K is fixed at K bar. This information is also being given. Price of L is being given as W. Price of capital is R, and we are also being told that the value of W is 12. W is equal to 12. Okay, we need to find which of the following options is or correct. Okay, so we are being told short run marginal cost is this very step, 6Q upon K bar. Okay, so what will we do? So what will be the total cost function? So C will be equal to W times price of labor plus R times price of capital. Okay, so total cost will be equal to, so W is 12, so can I write 12 times PL, sorry, I write it absolutely incorrect. So total cost will be equal to, so total cost function will be equal to wage rate times units of labor employed plus rental rate of capital times units of capital employed. Okay, so price of labor is W, price of K is R, and we are being told that W is equal to 12. So we have 12L plus RK, and K is fixed because we have a short run. In the short run, capital is fixed usually, always rather. So how do we find out the total cost function? So total cost function, what will we do? We solve this Cobb-Douglas production function. Let me see if I have the space. Oh, I have the plenty space. So Q is equal to twice L raised power 1 upon 2. Capital is fixed, so we have K bar raised power 1 upon 2. We need to solve it for L first. So can I write it like this? L raised power 1 upon 2 twice will be equal to Q divided by K raised power 1 upon 2, or L raised power 1 upon 2 will be equal to, transpose, it gets divided, so Q divided by twice K bar raised power 1 upon 2. Since we need to solve for L, so transpose the exponent, it becomes square. So L will be equal to, which will be equal to Q divided by twice K bar raised power 1 upon 2 whole square, or L will be equal to Q square divided by 2 2s are 4, and here 2 and 2 gets cancelled, so we get 4K. This is our demand for labor. Okay, now we plug this value of L is equal to this into the cost function. So our total cost will be equal to 12 times the value of L is Q square divided by 4 K bar plus R times K bar. Okay, and this is total cost. Okay, so we have 4 1s are 4 3s are 12. So we got total cost function is 3 Q square divided by K bar plus RK. This is variable cost, this is fixed cost because K is fixed here. Now we are supposed to find out the marginal cost. What is marginal cost? That is the change in the total cost due to the change in the output, that is Q. Take derivative with respect to Q. So derivative of Q square is 2Q, so 2 into 3 is 6Q upon K bar plus this is constant because K bar is a constant, R is also fixed. So 6Q upon K, it denotes the short-run marginal cost. So short-run marginal cost is 6Q upon K bar, it's correct. Now what about short-run average cost? Okay, since this is total cost, what will be the average cost? Rather average variable cost. So this thing denotes the total variable cost. Okay, and when we divide the total variable cost with, so this is our TVC, so it will be TVC divided by Q. So we have 3Q square divided by K bar divided by, we divided by Q, so we will get 3Q square divided by K bar times 1 upon Q. So Q is cancelled, so we get 3Q divided by K. So this is our average variable cost, 3Q upon K. This is also correct. Next option is to produce 10 units of output, required labor will be equal to 25 upon K. Let us see. So our demand function is this, labor demand function. So L will be equal to, so we are supposed to produce 10 units of output. So in place of Q we have 10, so 10 tens are 100 divided by 4K. So 4 ones are 4, 25s are, so L will be equal to 25 divided by K. This is also correct. Okay, I hope I have solved it correctly. For K is equal to 3, R is equal to 4, total cost is this stuff. Okay, so let us see. When K is equal to 3 in this equation, no, in what equation? Total cost equation. So this is our total cost equation. So C will be equal to, if K is equal to 3, so we have 3 Q square divided by K. Okay, so K bar is equal to 3. K bar is equal to 3 plus R is 4 times K bar is 3. So total cost will be equal to 3 gets cancelled, so we get Q square plus 12. So this option is incorrect. Okay, so the correct options are A, B and C in this question. The question is how to find out the expenditure multiplier. The question is, if the marginal propensity to consume of an economy is 0.75, then the value of expenditure multiplier will be, so we have marginal propensity to consume is equal to 0.75 and we are supposed to find out the expenditure multiplier. Okay, let us denote it by K. It is equal to the change in the output due to the change in the exogenous output, exogenous variable or autonomous variable. In this case, let us say the investment here. It is equal to 1 divided by 1 minus the marginal propensity to consume. So we have 1 upon 1 minus marginal propensity to consume is 0.75, which is equal to 0.25, which will be equal to 1 divided by 25 upon 100. So it will be equal to 100 divided by 25, which is equal to 4. So in this economy, the expenditure multiplier will be equal to 4. It simply tells us the value of K, simply tells us 4. This tells us if investment increases by 1 unit, okay, output, that is income, will increase by 4 units. This is the meaning of the expenditure multiplier. The question is about choice under uncertainty. The question is, consider the lottery with the 3 possible outcomes. In the outcome first, probability is 0.2 and rewards or win is equal to $25. In the second outcome, the probability is 0.3 with reward 50, and in the third outcome the probability is 0.5 with the win of 100. Let me put it another way, that is, there are 20% chances that the person will win $25. In the second outcome there are 30% chances that he will win $50. In the third outcome there are 50% chances that he will win $100. The maximum amount that a risk neutral person would be willing to play the above lottery is, we need to find out. Okay, now a risk neutral person would pay the expected value of the lottery to play it. Okay, so a risk neutral person would pay the expected value of the lottery to play it. Okay, when we have a risk neutral person, he will pay the expected value of the lottery. Okay, now what is expected value? Expected value is simply equal to the probability of each outcome times the payoff for each outcome. That is, expected value is equal to the summation of pi times xi. If I denote probability here pi and the rewards by xi, then what is the probability? So it will be equal to, so there are 20% chances, 0.2 times the outcome plus 0.3 times the corresponding outcome plus 0.5 times the corresponding outcome, which is 100, which is equal to 2 upon 10 times 25 plus 3 upon 10 times 50 plus 5 upon, so it is 1 upon 2 times 100. So it becomes 5 2s are 10, 5 5s are 25, 2 go mugs and toss. So we have here 5 plus 10 1s are 10 5s are 15, sorry 10 5s are 50, 5 3s are 15, plus here we get 50, so it becomes 50 plus 20, which is equal to 70. So the risk neutral person would be willing to pay $70 or rupees to play the above lottery. This question is related to homothetic and homogeneous functions and also about the MRS of quasi-linear and constant elasticity substitution functions. The question goes like this: a CES, that is constant elasticity substitution utility function, is given as utility is a function of two goods Z1 and Z2, which is equal to 1 upon delta times Z1 raised power delta plus Z2 raised power delta, where Z1 and Z2 are the two goods and delta is less or equal to 1 and delta is not equal to 0. We are being given the CES utility function. Okay, also a quasi-linear utility function is given as utility is a function of two goods again, which is equal to twice Z1 plus log of Z2, where Z1 and Z2 are the two goods. Which of the following statements is or not correct? We need to find out. It is a multi-select question and we need to find out the among the given options which statements are not correct. Okay, so first statement is a CES utility function is homothetic, but quasi-linear utility function is not homothetic. Okay, so by homotheticity what we mean? We know that a function f of xy, so a function f of xy is said to be homothetic. Okay, homothetic if it is a monotonic transformation of a homogeneous function. Okay, f of xy is homothetic if f of xy is monotonic transformation of homogeneous function. I cannot explain all the things here because I have already made the videos on homothetic and homogeneous functions. Okay, so To give an example, we are saying, let us say f of xy is a function. We say f of xy, it is a homothetic function if it is equal to capital F. Let us say we have a composite function g of x comma y. Okay, I am saying this f of xy is a homothetic function, okay, if it is a monotonic transformation of another function which is homogeneous. Okay, so g of x is a homogeneous function. F denotes the f, where f is strictly increasing function or monotonic transformation. Okay, so I can explain only this here. Property of homothetic function is, we say a function is homothetic, rather we can say every homothetic function is, every homothetic function function is homogeneous. Okay, it is one of the property. If a function is homogeneous, it is automatically homothetic function. Okay, so a CES utility function is homothetic. Okay, this function will be homothetic if it is homogeneous function. Okay, so how do we check the homogeneity? So let us take the utility function. Utility, we have the given function, and let us increase both the goods by a factor lambda. So we have u times lambda times z1 comma lambda times z2. Okay, should be equal to 1 upon delta times, in place of z1 we have lambda times z1 whole raised power delta plus lambda times z2 whole raised power delta, which is equal to 1 upon delta. So let's take lambda common. So we have lambda raised power delta times z1 raised power delta plus lambda raised power delta times z2 raised power delta. We can factor out delta, so we have rather lambda, so we get lambda raised power delta times 1 upon delta, then we get z1 times delta plus z2 times delta, which is equal to lambda raised power delta times the given utility function u of, because this function is again the given function, utility of z1 z2. Okay, so if we are able to factor out lambda, okay, from this equation, so we get a utility function, we get a homogeneous function. Okay, I have explained homogeneity also, I don't have the space and time here. So if we are able to, you know, take lambda common completely from this you know, function, we say the given function is you know, homogeneous of degree n. Here the degree of homogeneity is delta. So this part is correct. A CES utility function is homothetic. What about quasi-linear utility function? So let us see whether the quasi-linear utility function is homothetic or not. So let us increase both z1 and z2 by lambda. So we have lambda times z1 comma lambda times z2 will be equal to twice, in place of z1 we have lambda times z1 plus log of lambda times z2. So can we factor out lambda and lambda here? No, we cannot factor out this because it is with this z2 here. Okay, so if it is not like this, lambda raised power, sorry, lambda times x plus lambda times y, so we can factor out lambda and we get x plus y. Here we cannot take lambda out completely, so we can say the quasi-linear utility function is not homogeneous. If it is not homogeneous, it is not homothetic. Okay, so this is correct, but we are supposed to find out the incorrect option. Okay, so we are done with the first option. In the second, we are being told if delta is equal to 0, the CS utility function is not strictly convex. Okay, so we have this function. So u of z1 comma z2 is equal to, if delta is equal to 1, so we get 1 upon 1 times z1 raised power 1 plus z2 raised power 1, and we get here z1 plus z2, which is linear function here. Okay, so it is not strictly convex function. This statement is also correct. Now we have the next option, that is the MRS for CS utility function and quasi-linear utility functions are dependent on both Z1 and Z2. Okay, so let us see. Let us first find out the MRS of this function for what we call it CS production function. So MRS, as we know, it is equal to marginal utility of good 1 upon marginal utility of good 2, which is equal to the partial derivative of utility function with respect to Z1, that is mu1, divided by the partial derivative of utility function with respect to good 2. So let's take partials here. So we have 1 upon delta. Okay, so the derivative of Z1 raised power delta, it becomes, so we have 1 upon delta, derivative of Z1 raised power delta becomes coefficient, then we are left with Z1 raised power delta minus 1. Okay, and derivative of this will be obviously 0 because we are taking partials with respect to Z1. Symmetrically, du upon dz1 will be 1 upon delta times delta z2 raised power delta minus 1. This gets cancelled, so we get z1 upon z2 whole raised power delta minus 1. So MRS is dependent on z1 and z2 for CES utility function. So what about quasi-linear utility function? Let us take its MRS. MRS for quasi-linear utility function, that is del u upon del z1 upon del u upon del z2. Let us take it here. So taking partial with respect to z1, we are left with only 2. Taking partial derivative of with respect to z2 this time, so and derivative of log of z2 is 1 upon z2. So here we got 2 divided by 1 into z2 divided by 1. Here MRS depends upon only one good, that is z2. So this for CS utility function, MRS depends on both z1 and z2, but for quasi-linear utility function, MRS does not dependent on both z1 and z2. It only depends on one of the goods, which is z2 in this case. Okay, so this option, C option, is incorrect. Coming for the last option, that is if z1 is equal to z2, MRS is equal to 2. Okay, for both CES and quasi-linear utility function. Let us see for CES. Let us first find out for CES. MRS we have calculated, since z1 is equal to z2 here, so can we write it here, z1 upon z1 raised power delta minus 1, so which is equal to 1 raised power delta minus 1, which is equal to 1. Okay, so for CES production function, if z1 is equal to z2, MRS is equal to 1 and not 2, which are being told in the option. For quasi-linear, let us find out. So we got this, if z1 is equal to z2, here MRS is equal to twice z2. Okay, so it is not equal to 2 in either of the cases. So C and D options are incorrect in this question. This question is about how to find out the value for which the given system of equations have infinitely many solutions. The question is, Consider the following system of linear equations: x plus 2y plus 3z is equal to 0, x plus py is equal to 0, and 3x plus 2y plus pz is equal to 0. We have the system of three linear equations. We need to find out the value or values of p for which the system of linear equations have infinitely many solutions is or options are being given. We need to find out the correct option or options. It is a multi-select question. Okay, so given the three equations here, first we write them into the matrix form, that is in this form, that is a x is equal to b. Okay, where a is the coefficient matrix, x is the vector of the variables x, y, and z, and b denotes the vector of constant terms. We write the given system of equations in matrix form first. Okay, so a is the coefficient, so let us write it like this. So in place of a we have 1, 1 and 3, 1, 1 and 3. Then we have 2, p, 2, so 2, p and 2, and then we have 3. Since z is not here, it is 0, and then we have p. So this is our A matrix. X is equal to x comma rather x, y, and z should be equal to the vector of constant terms, which is here 0, 0, and 0. Okay, so the condition is like this. So if we have if the determinant of this matrix is equal to 0, is not equal to 0, let me put it like this first, then we have a unique solution. Unique solution. If one condition, if the determinant of A is equal to 0, then there are two cases. Okay, that is another sub condition is there. If at least one numerator determinant is 0, we have infinitely many solutions. And if the determinant of A is equal to 0, and another condition is if none of the numerator determinant is 0, then we have no solution. Okay, sorry. So here we are supposed to go in this direction. Okay, so first we need to find out the determinant of this matrix, that is the determinant of the coefficient matrix. So we write 1, then delete the row and column in which it appears and take determinant of the remaining element. So we have 1 times p square minus 2 into 0 is 0. Then we have minus from the formula, then we write 2 and delete the row and the column in which it appears and take the determinant of the remaining element. So we have 1 into p, which is p, minus 3 into 0, which is 0. Then we have plus 3, and we delete the row and the column in which it appears and take determinant of the remaining element. So 2 into 1 is 2 minus 3p. Okay, for infinitely many solutions, this determinant should be equal to 0. Solve it, we get p square minus, here we get 2p plus 3 2s are 6, then we have minus 3 3s are 9p should be equal to 0, or p square minus 11 Okay, so let me see if I have done it correctly or not. So we have here p square minus 2p, 3 3s are 9, somewhere I have done a mistake. So here we have 3. Okay, so when we have 3, we delete this and this. Sorry, here we have 2x. Okay, I have already solved this question. So here we have 2x. So here we have 2. Okay, so then in this equation 2 2s are 4. Here we will get 4. Okay, I was wondering how did I got it incorrect. So here 3 4s are 12. So here we have 12. Okay, so we have 2 2s are 4 minus 3p. Okay, 3 3s are 9. Still I am getting confused here. Okay, let me take the determinant again. So determinant will be equal to, which will be equal to, so we write the first term, then we multiply. So delete this row and column. So determinant of this what we can say matrix. So it is p square minus 2 into 0 is 0. Then we have minus 2. We delete the row and the column. So 2 into p is 2p. Minus 3 into 0 is 0. Then we have plus 3. We delete this row and this column, rather this row and column. So take determinant of the remaining element. So 2 2s are 4 minus 3p, and it should be equal to 0. So we get here determinant of a will be equal to p square minus 2 into 2 is minus 4p. Then we have plus 3 4s are 12 minus 9p should be equal to 0. So p square, so 9 and 4, it is minus 13p plus 12 should be equal to 0. Factor this out. So we will get p square minus 12p minus p plus minus 12 times minus p. Okay, what we have done, we separated the middle term in such a way that the sum of the two numbers should be equal to 13 minus 13, and product of the same two numbers should be equal to 12. So if we write here minus 12 and minus 1, so it becomes minus 13. Minus 12 into minus 1 is plus 12. Okay, so let's take p common. We are left with p minus 12. Here we take minus p common. We are left with p minus 12, and it should be equal to 0. Let us take p minus 12 common. So here it is minus 1. Sorry, we have taken minus 1 common here. Okay, so then we are left with p minus 1 should be equal to 0. That means either p minus 12 is equal to 0 or p minus 1 is equal to 0, which gives us p is equal to 12 and p is equal to 1. Okay, so the values for which the given system of equations have infinitely many solutions, for that p should be equal to 12 and p should be equal to 1. So this option and this option should be correct. So we have tested only this condition here. Okay, we don't need to test this condition. For that, what we need to do, we need to solve the given system using Cramer's rule. That is, first we need to find out another matrix, that is A1. So to find out the value of x1, what we do, we replace the first column of the coefficient matrix with the vector of constant terms. So we have 0 0 0 in place of 1 2 3. Then we have 2p 2, then 3 0 p. Okay, so this is A1. That is, this will give us, if we take then the determinant of A1, okay, then we will get the value of x1 will be equal to the determinant of A1 divided by the determinant of the coefficient matrix. Okay, this is what we call the numerator determinant here. And similarly for y, we need to form another matrix, that's A2, and we take its determinant and divide it by the coefficient matrix. And similarly for z, we form A3 by replacing the third column in this case and divided by the coefficient of matrix. So for infinitely many solutions, we should have two conditions. First, the determinant should be equal to 0. That is, we are done with the question, but I am explaining what is meant by the numerator determinant. So if at least one numerator determinant comes out to be 0, then we will have infinitely many solutions. We don't need to solve it further because we got the two values for which the given system of equations have infinitely many solutions. Okay. This question is related to ISLM model. The question is, consider the following ISLM equations. Y is equal to 490 plus 0.6 y minus 4r plus g. This is our IS equation. And we have ms upon p bar is equal to 20 plus 0.25 y minus 10r. This is our LM equation. Okay. Here y denotes the output, r denotes the rate of interest, g denotes the government's expenditure or spending, ms denotes the money supply, p bar denotes the general price level which is fixed, is equal to 20 plus 0.25 y minus 10r. Okay, where the symbols have usual meanings, I have cut it short because I don't have the space. If government spending is 330 and real money supply is equal to 500, then equilibrium level of output in this economy will be, we need to find out. Okay, so let's take the first IS equation. So we have y is equal to 490 plus 0.6y minus 4r plus the value of g is being given us is 330. Okay, so we need to solve it for y here. So y minus transpose it here, it gets subtracted. So we get here 490 plus 330. I have done the calculation. It comes out to be 820 minus 4r. It becomes 0.4y is equal to 820 minus 4r. This becomes 2 upon 5y is equal to 820 minus 4r, or y is equal to 820 into 5 upon 2 minus 4r into 5 upon 2, which gives us y is equal to, solving this we will get 2050 minus 10r. This is our IS equation. Okay, in reduced form or in simplified form. So what does IS equation tell us, or IS curve? It simply shows us if we have the output on the horizontal axis, rate of interest on vertical axis. Here you can see there is negative relationship between the level of output and rate of interest. So it will be a downward sloping curve. Okay, so IS equation simply shows us the goods market equilibrium. Every point on this what we call this curve shows us goods market equilibrium. It shows us different combinations of rate of interest and level of income for which the goods market is in equilibrium. Now we need to find out LM equation. So ms upon p, which is real money supply, that is being given us as 500. So let us write it here 500, or let me first write it on the LHS side. So we have 20 plus 0.25y minus 10r is equal to ms upon p. It is being given us as 500. Okay, this simply tells us, this denotes the demand for money, this shows us the supply for money. Demand for money is a positive function of income and negative function of rate of interest here. Okay, so this denotes the transactionary demand for money, this denotes the speculative demand for money. I will not go into detail here. Let us solve it again for y. So we have 0.25y minus 10r is equal to 500 minus 20. So this is 1 upon 4 y minus 10r is equal to 480, or 1 upon 4 y is equal to 480 plus 10r, or y will be equal to 480 into 4 plus 10r into 4. Solving further, so y will come out to be, in this case, So what we got here, 820 minus 4R, so it will come out to be okay, let's do the calculation here. So 4 zeros are 0, 4 8s are 32, 4 4s are 16, 17, 18, 19. So we got 1920 plus 10 4s are 40R. So this is our LM equation. So what does LM equation tell us? So it shows us here there is positive relationship between the level of output and rate of interest. So it is LM curve. This is our IS curve. It is upward sloping. It shows us different combinations of rate of interest and level of income for which the money market is in equilibrium. Okay, for simultaneous equilibrium, IS should be equal to LM. Okay, so this is our LM equation. So we solve, this is our equation first, equation second. So from equation first and second, since the LHS is same, we can equate the RHS of both the equations. So we have 2050 minus 10R is equal to 1920 plus 40R. Okay, transpose this here, so we have 2050 minus 1920 is equal to 40R plus 10R. So this comes out to be okay, solving this, it will come out to be 130. Okay, so this is 40 plus 10, which is 50. R is equal to 130, or R is equal to 130 upon 50, 130 upon 50. So this gets cancelled. We got 30 upon 5 is the rate of interest, but we are supposed to find out the equilibrium level of income. We plug the value of R is equal to 13 upon 5 either in IS or LM equation. So let us put it into the IS equation. That means our Y will be equal to 2050 minus 10 times 13 upon 5. So we have 13 upon 5. So here 5 ones are 5 2s are 10. So 2 13s are 26. 26. So we got 2050 minus 26. It will come out to be 2024. So the equilibrium level of output in this economy will be 2024 will be the correct solution. So let me see if I am within the limits. Now I am within the limits here. Okay, this question is related to the savings function. The question is, for a closed economy, if marginal propensity to consume is 0.9 and initial savings is $120, when income rises by $100, then new level of savings will be, we need to find out. Okay, so we are being told that marginal propensity to consume is equal to 0.9, initial savings, let's denote it by S, which is equal to 120. We are being told that income rises by $100 and we need to find out the new savings. Let us denote it by S superscript N. Okay, so if MPC is 9, we know that marginal propensity to consume plus marginal propensity to save is equal to 1. So if MPC is equal to 0.9 plus MPS will be equal to 1, or MPS will be equal to 1 minus 0.9. So marginal propensity to save is equal to 0.1. Okay, first we were supposed to find out the marginal propensity to save. Now, given this information, change in the savings due to the change in the income will be equal to, so change in the savings will be equal to the marginal propensity to save times the change in the income. So change in the savings will be equal to marginal propensity to save is 0.1, which is 1 upon 10, times del Y is equal to 100. So this gets cancelled. So change in the savings is 10. So del S is equal to 10. Now new savings. Okay, so new savings will be equal to the initial savings, which we denoted by S, plus the change in the savings, which we found out here rather. So S superscript N, which is the new level of savings, will be equal to the initial savings, which is 120, plus the change in the savings, which is 10. Okay, so I am out of limits. So new level of savings will be equal to 130 in this question. In this video, we will solve the questions asked in GATE Economics paper of 2025. The question is, consider the following Harrod-Dommer growth equation, that is S upon theta is equal to G plus delta, where S denotes the savings rate, theta denotes the capital output ratio, G is the overall growth rate, and del denotes the capital depreciation rate. If depreciation is equal to 0 and savings rate in the economy is 20%, then to achieve a growth rate of 10%, the capital output ratio will be, we need to find out. Okay, so we are being given the growth equation, that is S upon theta, that is equal to G plus delta. Also, we are being told that the depreciation rate is 0, savings rate is 20%, and growth rate in the economy is equal to 10%, and we are supposed to find out the value of capital output ratio. Okay, so it is very pretty, rather it is a simple question. Now we plug the values in this equation, that is savings rate is 20% divided by capital output ratio. We are supposed to find out growth rate in an economy is to be 10% and depreciation rate is 0, which implies 20% divided by capital output ratio will be equal to 10%. Okay, so cross multiply. So we have 10% times capital output ratio will be equal to 20%, which implies theta, which is the capital output ratio, will be equal to 20%. Transpose this 10 here, it gets divided, so it is 10%. So 20% upon 10% is 2. That means the capital output ratio in this economy will be equal to 2. By capital output ratio, what we mean? How many units of capital are required to produce 1 unit of output? By 2, it means in this case that we need 2 units of capital to produce 1 unit of output, given the Harrod-Dommer growth equation. I hope I make myself clear in this video. Thank you.